Solving trigonometric equations, worksheet 2 solutions. Solve for x in the interval 0 to 360 degrees or 0 to 2 pi. Equation given to us is 3 cos x sin square x minus cos x equals to 0. Well, one way could be that you convert sin square x into cos square x, but that will land into problems. You notice one more thing, that is you can take cos x common, right? So that may help you to solve this problem. So let's try doing that. So we'll factor out cos x. So we get what? We get cos x, and within brackets we get 3 sin square x minus 1 equals to 0. So that is a better result. So now we have two solutions here. Either cos x is equals to 0 or 3 sin square x minus 1 equals to 0, correct? So cos x equals to 0, you know the solutions for that. So if you draw your cosine graph, you know cosine graph is kind of like this, right? And cos x is 0 at 2 points. So these are the possible solutions for cos x equals to 0. On the other hand, we get sin x equals to, let me first write sin square x equals to 1 over 3, and then sin x is equals to, whenever you do square root, don't forget to do plus and minus, right? So we get sin x equals to plus and minus square root of 1 over 3. Now that gives us how many solutions? 4 solutions, because 1 over square root 3 in all the 4 quadrants, right? So we have a solution here, we have a solution here, here and here. 4 solutions, right? And what is the value? It is one of our standard triangles, correct? So we can make our standard triangle and figure out what the real answer is. So standard triangle for 1 over square root 3 is 30, 60 and 90, correct? It is a good practice to remember this, right? So this side is 2, this is 1, and this is square root of 3 for us. And the angles are, here we have 60 degrees, 30 degrees, correct? 30, 60 and 90, correct? Now you want 1 over square root 3, right? So it is, okay, sorry. So that doesn't really work. It is square root 3 over 1. So that doesn't really work. So 30, 60, 90 is not a solution. So we basically need the calculator this time, right? Okay, so we'll do 1 over square root 3 and then figure out what this answer is. So we'll do square root of 1 divided by 3, which is equal to, okay, and then we'll do sine inverse of this, right? So inverse sine equals to 35.26. So we get acute angle of 35.26, right? That is the acute angle, correct? So, well, I got confused. I thought it's like square root 3 over 2. Okay, anyway, so it is actually 1 over square root 3. So for that we don't have any special triangle. So we used our calculator to figure out the answer. So the answers for us are 35.26, which I could round to 35 point, let's say 35 degrees, okay, approximately. Let me write this answer approximately to 35 degrees, correct? Now, so 4 answers for us are what? So we have 35 degrees in all the 4 quadrants. These are the acute angles, right? So what we can do now here is, so we have answers, solutions as, let me write down answers for this. First is 35 point, let's say 35 degrees, okay, 35 degrees. The other one, since it is not specified about the accuracy, we can go for rounding to the whole number, 35 degrees. The other one is 180 minus 35, 180 plus 35. So let's calculate. So let me first write down here 180 plus minus 35 degrees. These are the 2 answers. And the third is, or rather the fourth is 360 degrees minus 35. So those are the answers which we get from the second factor, and from here we get the answers as 90 degrees and 270 degrees, right? So we also have solutions as 90 degrees and 270 degrees, correct? So these are all the possible answers for the given problem, right? So let's calculate all these answers and write them down. So it is 180 plus 35, which is equal to 215. So let me write all the answers again. So one is 35 degrees, the other one is 90 degrees, and then we have 215. 180 minus 35 is equals to 145, 270, and 360 minus 35, which is equals to 325 degrees. So these are all the possible solutions to our equation, correct? So at times when you can't get the special triangles help you out, use your calculator and find sine inverse and get the answer, right? Thank you.